So welcome guys after a long break. So we'll start today's session on OpenStack. Last time when I left, so I covered most of the topics related to OpenStack. I discussed very basic cloud technology, like what exactly was cloud, from very basic scratch level understanding of the cloud technology and how different type of services we are getting from cloud providers. So out of different services which we usually get from cloud service provider, the very first service in cloud technology is infrastructure as a service. Infrastructure as a service means we virtualize our whole hardware, that is physical server, physical storage, physical networking into virtual format. And then we create our own virtual data center. Other services are also other formats like platform as a service, software as a service, function as a service, code as a service. There are different type of services ongoing in current scenario in the cloud technology. But the very I can say very basic service which cloud started was infrastructure as a service. Then it moved from infrastructure to platform, and then from platform towards software, then function, code, and different type of services. So we are basically going to talk in today's session about infrastructure as a service, and the example of infrastructure as a service is OpenStack, open software which will help user to convert the physical data center into a virtual data center. So if I say definition of OpenStack, it's like it's a piece of software which transforms your physical data center into a virtual data center. So what input you are giving? Physical data center, your physical servers, physical storage, physical devices. And what output you are getting? You're going to get virtual machine, virtual network, virtual storage. These are the five layers of any software stack, which is important, valid. This is a universal stack. So it's not like it will change, or you cannot remove any one of the layer. You can only do is that you can decouple. Decouple means you can give roles and responsibility to someone else, that is to your cloud service providers. So these things I discussed already in the previous sessions, like how the virtual format is getting converted. We started about the community. In this class, we are discussing OpenStack software. So OpenStack software is coming from the Open Infra community. So this project started in 2010. It was a joint venture between Rackspace and Anso Lab. Anso Lab is a contracting of NASA who are working for NASA. So this community was formed, Open Infra Foundation, which is previously known as OpenStack Foundation. This community manages the OpenStack software architecture and everything. So it is a non-profit organization to promote open source software in market. So they are doing research and development. They are creating this software. They are managing the software. They are doing the life cycle management, releasing new software versions, and in turn, like industry leaders, they are using these softwares to build their own products. So they are taking this technology, they are creating their own OpenStack. So you will find Red Hat OpenStack, you will find Mirantis OpenStack, you will find Ubuntu OpenStack, you will find different type of OpenStacks in different companies. But at the inside core, you will find same OpenStack software. So this was all about release cycle and these things which I have already discussed. So this was complete picture of OpenStack ecosystem, but I see I'm not going in detail in all of the services because this is a huge portfolio, and portfolio has so many services which we even don't need for our requirement. But still, like as I said, it is a community maintaining and doing lifecycle management, releasing new softwares. So definitely from documentation or knowledge point of view, suppose in today's use case, you may not be using, for example, Cyborg, or you may not be using any of the tool mentioned here over here. But yes, if you know, then you can propose to your company to start using this software. So in this way, it can be helpful for you that yes, you understand the complete portfolio catalog of OpenStack, what type of services or what is possible with OpenStack, and what you see in your company could be a limited portion of that particular complete portfolio. So this thing we discussed that we have, I'm just doing a refresh of what we have studied till now. So I'm just doing a basic refresh for people who are new in today's session. So I'm just doing a basic refresh. So over here we have division of the nodes. So when we say division of the node means the physical server. So very first server in the starting three server we call them as controller node. So controller, as the name suggests, it is going to control your OpenStack architecture. Means it is not going to participate in any kind of VM launching, but it is going to control whole OpenStack platform, because launching a virtual machine is one of the service, but this platform should be maintained, managed by some node. So this is the node who is going to control the complete architecture. Here, if you see, it is compute node. So this is the actual node where your virtual machine will get deployed. So your virtual machine will get deployed in this node. Here is another node called storage node. So what happens, like because you see this OpenStack, you are building a data center. So cannot restrict yourself to you cannot restrict yourself to simple uh, 4 or 5 hard disks or 1 or 2 TB or 100 TB of capacity, because that is very less when you provide a complete data center. When you say complete data center means your capacity should be huge. It should be in petabytes. It should be very huge, even more than terabyte. So therefore, you cannot accumulate those hard disks in a single host, in single compute node. You need to have an external storage. External storage will be your external EMC storage, Unity storage, Dell storage, any kind of storage you can take, any storage servers. So this storage node is basically representing that particular storage node. So it is not your physical server, rather it is a storage node. That storage node could be your EMC, it could be Dell, it could be HPE, it could be anything. This whole complete data center, also you will be having your networking is also part of your OpenStack. So these things, when you combine together, it becomes your OpenStack. Now these are the architecture. So see, this was about your deployment scenario, so I think let's not talk about the deployment scenarios. See, this I have already discussed. If you need any further clarification, we will take it later on, but today's objective, I'm going to cover about the services of OpenStack, because these things, basic things, I've already covered. Triple O architecture, where you deploy under cloud, basic OpenStack. With the help of that OpenStack, you deploy complete production OpenStack. So this is called as triple O, OpenStack over OpenStack. This is one of the very famous method of deploying OpenStack for any commercial systems. So when you deploy OpenStack for any commercial operator or commercial user, you go with this triple O approach. This is very famous, but it's not like only triple O is there. There are other method also. But I prefer to explain you triple O because this is what I see in my industry also, and I hope other industry companies are also following similar things. So these are the requirement if you want to deploy your OpenStack. So physical requirement, you should have controller, compute, block storage, and object storage. So again, question is block storage and object storage. This I have explained multiple times. But yes, if anyone has any confusion, definitely I will discuss on this part also. So these are the requirements that you should have minimum. When you see this plus sign, that means it is a minimum. So you should go more than that. This is something which you cannot go beyond 100 GB for your compute. So if you go beyond 100 GB for your compute node will not work as per design. So you should go more than 100. External storage, yes, definitely you should have external storage. You should have block storage and object storage. These are the two different type of storage technology which we are using in our industry at the moment. So block is something where you have volumes, then you have object storage. In object storage, you have you have your uh, in object storage. See, basically what happens, that you use a library structure. In library structure, you save data not only in the normal traditional format, that you put everything in a same sector of your disk. Rather, you let the vendor who is providing you this service decide how he want to store the data based on the data structure. So what he does, he exposes some metadata API, and whenever you need to call any particular data, you just need to call that metadata, and you will get your storage. You will get your data part. So this is something related to storage technology. These are the services. Node wise, I have mentioned, like role wise. So if you have controller, So these are the services which need to be installed and be up and running at any point of time. Then for compute node, you should have hypervisor, you should have networking, and then you should have a telemetry. Telemetry is something your measurement. So if you don't want to have any kind of resource management, like what is your resources, CPU resources, or your RAM or storage you are utilizing for your VMs, then you can skip this. If you don't want any monitoring, so you can skip this telemetry service. So it is an optional, not mandatory. Then you should have minimum 2 nodes for your compute. If I go previous slide, you will see minimum 3 nodes should be deployed for controller. So controller in any commercial setup should have minimum 3 node. I'm saying minimum. Maximum it's like on your design how you want to take. Then your compute node should have minimum 2 because you are going to launch your virtual machine on top of these compute nodes. So if you don't increase your compute, definitely you will not have the capacity to launch more virtual machines. Then your block storage node and object storage node. This one I explained already. So these are the services which are running in OpenStack as per node wise. So controller node has these services. Open like compute node has these services. Block should have these services, and object storage node should have these services. Then also I explain how this triple O is controlling or managing the complete commercial OpenStack. So this under cloud basically act as a life cycle manager. Life cycle manager, what is life cycle manager? Like you have a commercial system, you do first time deployment, then you might be having some upgrade activity. You want to upgrade your software. You can have your expansion activity. You want to increase your capacity. You can have your scale in. You want to decrease your capacity, or you can have any maintenance activity where you want to shut down your any particular physical server. So everything can be done with the help of this under cloud. You don't need to connect the over cloud architecture for making any particular controller down or particular compute down. The same task can be done with the help of under cloud manager, which is basically life cycle manager. And it is again a open stack. So this is a very basic OpenStack, and it talks to the complete commercial setup, and it does like it divide. When you do first time deployment, it will divide, it will do installation of your physical servers based on the rules. So it will select first 3 node as a controller node, then other node as compute node. If you want to like deploy storage node, it will connect your storage node also. So these things are done with the help of under cloud. See, this is this terminology which I'm using OpenStack over OpenStack Triple O is from the community OpenStack software. So community definition says Triple O. When you go with the vendor specific OpenStack, for example, if I take an example of Red Hat, so in Red Hat they call this under cloud as director node, and this as the main OpenStack architecture compute controller. So terminology, basic terminology is under cloud, over cloud, triple O architecture. But yes, if you go in different vendor OpenStack, you will find some change in the terminology they do. Like Mirantis, they call it as fuel node. So they have different terminologies used. Now, how the open service stack services communicate with each other. See, this is very important, very important. In OpenStack, you have n number of services. For example, you have Keystone, you have Horizon GUI, you have Neutron, you have Glance, Cinder, Swift, Manila, Nova. Other than this, you have other services also, which I have not even discussed right now. But you will be having n number of services in OpenStack, not relevant to your requirement or use case, not even installed also, but I'm talking from community point of view. There are huge number of services. Now, when one service need to talk to another service, means there is a use case where Horizon need to talk to Keystone or Horizon need to talk to Glance, Neutron, Cinder, Swift, or Manila. How this communication happens? This happens with the help of a messaging queue. This is called as, so example is RabbitMQ. So this is one example. It is not mandatory that you should go with RabbitMQ. You can go with any of the messaging queue software which you find relevant for your use case. But OpenStack community has recommended to use RabbitMQ because they have tested it. So point is that they have tested it and they are sure RabbitMQ is perfect for their solution. If you believe that yes, I don't want to go with RabbitMQ, yes, you are welcome. You can go and use select any other messaging queue. So what is this messaging queue? See what happens when you talk, when this service talk to another, it basically provides you a channel. Channel means request come from here, request goes to this channel, this particular destination. Response comes back and it's sent back to this particular original sender. So this is the communication channel. So it is basically providing you a channel. Like we say road. So if you want to go to your office, you take road. If you want to go to your friend's house, take road. So road, what it is providing you? It is providing you a channel so that you can drive your car by any other vehicle or public transport and you can just simply reach your destination. So this is what RabbitMQ is doing in OpenStack. Okay, now let's see other things. So I explained VM instantiation flow last time when we left our class. So when the class was suspended, we were on this topic, how a VM is launched in OpenStack. So when you connect OpenStack dashboard GUI or you run OpenStack CLI command, both the ways, either way, you when you send a request to create a virtual machine, request first dashboard connects you to this is your channel. So remember, always remember, whatever you are doing from Horizon GUI or whatever you are doing from OpenStack CLI command, it has to pass from your messaging queue, this channel. This channel will do your authorization, so it will have a keystone authorization because it is important for you to authorize your user. What are the privileges you have? Which project access you have? What are the roles and responsibility you have been assigned? Whether you can access particular resource or not. So everything is decided by this keystone. It is your identity and access management. Once this is done, authorized, then what happens? It will take, you will go to the dashboard GUI, the GUI will open for you, and you will go and launch your VM. You select resources, whatever information you select, then you first click on submit button. So when you click on launch instance, so when you click on launch, what happens? That again this messaging queue comes in picture. Request comes to here, it is received by the API server. See this call flow I explained so earlier, so I think you can check previous recording if you want to have a detailed overview again of the call flow. I'm just giving you on high level that how this happens. API, then database, then conductor, Nova Compute, hypervisor, scheduler. These are the services. Then also your Nova API need to talk to Cinder, it need to talk to Neutron, it need to talk to Glance for getting your image, for getting your network, for getting your storage volume. So everything it need to map to your particular hypervisor. So this is your hypervisor. So all these actions happen when you launch a virtual machine. So this is the call flow. So if you are going to appear for any interview, so be ready. They may ask you how a VM is launched in OpenStack. So you need to understand this particular call flow. Don't memorize it because if you memorize, you will lose it. Understand how it is happening. Yeah. Anyone has any questions?
Yeah, Krishna, probably if we can just
Okay.
from the CLI, you are saying that
Mm-hmm.
yeah, from the OpenStack CLI client, you invoke first. You are creating a VM or what? How it is like?
Okay. So see here, GUI and CLI are two ways to interact with OpenStack. So for example, if I have to launch a virtual machine, so the use case is that I need to create a virtual machine. So there are two way possible. If I prefer to go with the GUI approach where I can see everything and I make selection, so I can go with the GUI dashboard. But if I want to have run this command from command line, like I have a third party tool which can do this lifecycle management, it can, I want it to create a virtual machine rather than me going and doing this task. So I create a program and that program runs on some different machine. Now that machine need to submit request to this OpenStack front end. So here the front end will be OpenStack CLI. So OpenStack CLI basically what happens? OpenStack has an API similar to what I discussed just now in the Kubernetes class. So it has an API. So that API should be invoked. So OpenStack has what OpenStack what community has done. They have created a tool called OpenStack Client. So OpenStack Client is basically a tool which you can install in your setup also. It means you can install in this particular OpenStack environment also, or you can install this particular client somewhere else, some third party remote entity. What will happen? That client will establish a connectivity with the API server. What is the API server? Here API server is referring to your Keystone. So Keystone, when you connect to the Keystone, what Keystone will do? It will do an authorization. So you will provide your credential, and based on your credential, it will provide you a token. That token will be used for submitting all future requests. So it has some validity. So it is like time-based token. So with some expiry date, expiry time duration, and you will submit your request. So what is your request? So you want to create a VM. In order to create a VM, so I am pre-assuming that you have all the resources in place. Means you already have image uploaded, you already have network created, you already have volume if you want to attach a volume. You have done all the basic prerequisite already, and now you are going to launch a virtual machine. So you need to submit your request. So the moment you submit your request, you say OpenStack server create, and then you give the arguments. Arguments mean you give name of the server, you give input like which flavor it should take, which network, which volume it should pick, what should be the port, all those information, affinity, server group, security group, key pair, all these things when you give as an input, then what happens? The request comes to your messaging queue. Means see, messaging queue is not an front end to handle request. Rather, it is a channel. So here you have an API server. API server is basically your front end communicator. So front end communicator means everything is coming on that API server, and then API server first going to check your information. So it is first going to do the authorization that you have requested to create particular virtual machine. That virtual machine, first thing is whether you are allowed to launch a virtual machine or not. If yes, then what is the role? Means what are the privileges you have? For example, you say you are using some network and that network is not authorized for you. So that means you cannot use that network. So all those things will be coming from this keystone identity. So it is not going to say you are authorized to use network. No, it is just going to authorize your user and going to provide a token. Now this token will be taken and it will be sent first to the Nova API. API is your front end for Nova Compute service. Nova Compute is basically your Nova. What is Nova Compute? So Nova Compute service, complete Nova service is basically used for launching a virtual machine in OpenStack. Now this is the front end of the Nova API. So it will take request. So whenever this request is coming from this API server, it will first go to your Nova API. It will go to Nova API. Now Nova API will first check the database, whether whatever VM name you are saying, whatever information you are giving, it will just create an entry. Means it will just simply create a template in database that the user want to create particular virtual machine with this information. So suppose if you are launching a virtual machine and that name is already present, then what it will say? That name is already present and that request will fail. And it will again come back to you that yes, this request has failed. Now what happens? If it is passed, that VM is not present, what it will do? It will write that information in the database. Means it is just simply creating an entry. Your VM is still not launched. Once it is created, then Nova API need to give information to Nova Compute, or it need to talk to Nova Compute. Now, Nova Compute is your actual node which has the capability to launch virtual machine, but it is not going to launch virtual machine immediately because it need to fulfill some resources. So what are the resources? It will first talk to your Nova conductor. It will go to database to check your information that whatever information this API has given is correct or not. It will talk to scheduler to understand that which particular host I should select for launching that particular VM. Means if you have any rules or if you have any privilege, in OpenStack we have a concept called zoning. So if you create a zone, so that means if you put three compute node in one zone, that means you are restricting your VMs to launch only in these physical servers. So your VM will not go in fourth node because you have already restricted with the help of a zoning. So it will check all those things. Then it need to launch your VM. Then it need what it need. It need your image, your VM image. It need network. It will need sender volume. Now the moment it send request to Glance. So when it is sending request to Glance, it also takes the token. Which token? Which you have been given by this keystone. So for my user, I receive some token based on my authorization. That token will go to Glance. Glance will validate. What it will validate? It will very first thing it will do is that it will check whether your token is correct or not. Because you can present some different token also and try to access resource. So it will first talk to Keystone and it will say, confirm me that this token which I have received from user is correct or not. So when Keystone says yes, this token is correct, I have issued this token, then what it will do, it will open the glance menu. So in glance menu, user will see the images which are accessible, and it will give an option to download this particular glance image, and it will download that image. Then it will go to Neutron, then compute. See, now it is going to Neutron. Neutron, again, same thing. It will take the identity, that token which has been generated. Neutron will also validate with this. Yes, is it correct or not? It will say yes, correct. Then it will open all the networks which are available for that user, and then it will send. Then it will go to Cinder. Cinder to see volume, what volume you have requested. Before that, it will do a pre-authorization that the token which you have provided is correct or not. So it will talk to Keystone, and then Cinder will do authorization. Once authorized, it will open the all the volumes available for your user. Once all these three resources are in place, and scheduler has already confirmed which particular host I should select, then it will go to Nova Compute. Nova Compute, provided it has everything, all thing in place, then it has this service called hypervisor. So hypervisor is basically a local service. Hypervisor, you know that it is your what we say, on operating system, before operating system. So on hardware, on top of hardware, we install hypervisor. Hypervisor is a very thin layer of software, very thin layer of software, which transforms your physical hardware into virtual machines. So if provided this hypervisor is mapped to this particular compute, Nova Compute, and then it will launch your virtual machine. So this is the complete VM instance launching process in OpenStack. So this is definitely asked. Yes, one more thing. When you complete this process, you need to inform. You need to inform your user your transaction is completed. You also need to update database that yes, this particular VM is now created and it is up and running. So you have to inform this to Nova database. Now here you can see there is no way possible to access database from queue. Means this service Nova Compute, if it want to access Nova database, it is not possible because this database has been hidden from outside world. No one can directly send request to Nova database. Rather, it is done with the help of this Nova Compute. Nova Compute, what it will talk, it will say give to Nova Conductor, or it can give to Nova API. So API also has an option to talk to database, and also Conductor has an option to talk to database. But Nova Compute cannot directly send request to Nova database. You can ask this question why it is so, because this has been designed in such a way to prevent any misuse of the VMs which are being launched in the OpenStack environment. Because community don't want to expose the database, Maria database, directly to the compute node. So someone, if for example, if hacks to your OpenStack environment, and if the person has access to your database, then that person can modify that particular any VM state. So this is the reason this database is not exposed directly to any outside entity. So this is the call flow for launching an VM. I hope I was able to explain you.
Yeah, Krishna, it was a good understanding now. Thank you. But just a quick thought which is coming in the head is like
Mhm.
probably it may be better to have a sequence flow also. But I got it now,
Yes,
got
yes,
that
yes.
understand. But for such kind of diagram, I believe like I know like it is a time-consuming act to prepare the sequence diagram. But nowadays we know that, right? It is online also. There are many languages available which you just put it on online and this can create a sequence. I'm happy to do that, Krishna, in case you need later on. I'm happy to do that a sequence diagram and other thing also during my weekend times. Anytime if you
Oh,
need, Krishna, between us.
yes. Yes, sure. Thank
Yeah.
you. So definitely, yes, we will include a sequence diagram. They will definitely help everyone to understand what is the first call for, what is second, third, fourth. Yes, we will
Yeah.
have that call
Once
flow.
that maybe you and me can have a separate half an hour kind of thing, and then later on I can draw and then send it to you if you need. Not only for this, but for any other purpose.
Okay. Okay. Sure.
Yeah.
Sure. Thank you. Thank you very much.
Thanks.
I will. I will connect you on this part. Yes.
Yeah. No worries. Yeah.
Okay. Thank you. So let's move to the next, which is our today's agenda. So today's agenda, I'm going to talk about the OpenStack service design concept. When I'm talking about this slide, so see this slide you will not find. This diagram I searched everywhere, but I was not able to find. This I have created myself. based on my understanding about the OpenStack services design. So it is not talking only about Nova or Cinder or any one specific service. It is talking about the whole OpenStack ecosystem. Whenever a new service is designed, what is the principle they are following? So the principle which OpenStack has followed till now is that in OpenStack community till date, what they are doing, each service is considered as a separate project. Means each service has its own way of developing and they are doing it independently. Independently means they are not dependent on each other for developing services. So how what happened? It actually creates a complex system, complex design because if every service is designed separately, definitely the overall diagram will be a very complex and tidy one. So therefore, they have some principles which they have followed. So one of the major principle is listed here. It is not mandatory what I am writing here is the correct one. See, it is just to give you an understanding how any service is designed in OpenStack. So what happens? The very first thing is like if I have to design this service called service one. Okay, service one. Let's take it is service one. I'm not giving any name. And there is another service called service two. When this service one was getting designed, service two was not there. And service two, in parallel, they are doing their task independently. They are designing their own services. What happens? The very first thing you design is the front API server, front end API server. So what exactly is this front-end API server? It is basically a REST-based, not GUI, I will say. It is basically a REST server. What REST server is doing? In REST server, you have the communication channel. So if you want to communicate, for example, I am a user outside sitting. I want to talk to this particular service. So what is the way possible? Use this API and then talk to the API of this particular service. In backend, there are multiple ways. See, you have a database. This database is a MariaDB in OpenStack. In OpenStack, we are using any open source database you can use. So there are two type of databases. One is structured, another is unstructured, non-structured. So structured databases are those databases where you define your table. You define your attributes that this table, in this table, these values are going to come with this specific range, this specific dimension. If any data you receive out of that range will be discarded. That is your fixed structured database. Now you have another type of database which is called as unstructured, where you don't know what type of data could come. Suppose today you have 7 fields coming, tomorrow you can have 8 field also coming, 9 field also coming, you can have even 5 field also coming. If you go with structured database approach, your database will fail. If you go with unstructured database like you have Elk, Elasticsearch, and there are other databases also where your database learns from what information you are giving, and even if you give less information, it can still process that data. So OpenStack supports both structured and unstructured. Example I am taking is of structured one. So here we have a structured database and we are going with the open source database technology. So we have MariaDB. You can take another database also. So it is not fixed that you go only with MariaDB. You can take your own database also. This database is divided into different services instances. So suppose I have service one, it will be service one instance. I have service two, it will be service two instance. Now, whatever information you are processing from your front end, it should be like created or updated in your database. That is the whole approach of your having database. Why? To have the consistency of information. At any point of time, you can retrieve whatever information you have processed. Now you can do this front-end communication for read operation to read from database to validate whether whatever query your user is sending is correct or not, or whatever information you want to do get. So simple get operation you can do. In get operation, you can see, well, okay, this particular table exists or not. This particular table, what is the status of that particular record? But only with front end you cannot achieve your whole service. You need to have services, different services. So here I have written service one and service two. See, it is not like you have two services or three services or four services. You can have services depending on your use case. When I say use case, na, I will explain this what I mean by use case. Before that, let's see. if this service when I design, so suppose I design this service and tomorrow I want this service to talk to another service. This is service 2, which could have similar kind of design. The principle remains same, but it can have service only one service, or it can have only, in fact, 5 service also. Now, whenever I want to talk to the second service, there is always a queue channel. This is a channel which we call it as advanced messaging queue. RabbitMQ is a preferred software which we prefer, but you can have anyone also, whatever you like. So here, suppose if this service want to talk to front end of this service, API server, it should go with this channel. If this service want to talk to this service, it should go with this channel. If service want to talk to this service, it should go with that channel. You will not find a case where one service is talking directly to each other. Here also, the design has been done in such a way that front end cannot directly talk to your service one, or it cannot talk to service two. It should go with the messaging queue. That is a standard designed in the OpenStack architecture. Any service, I'm emphasizing on the word service. Any service which we have designed, if it want to talk to each other, it should go with the messaging queue. It should go with this messaging queue. Now let me come back to a correlation. So let's take this Nova. Nova, you can see here. So this is your service one. And here you have, for example, take Neutron. So Nova want to talk to Neutron. So here you can see this is Nova front-end API server. Then it could have Nova. So you can take case of Nova scheduler, Nova compute, Nova conductor. See, hypervisor is not a service of OpenStack. Please remember, hypervisor is not a service in OpenStack. The service in OpenStack is called as Nova compute. Nova compute is actually connected to hypervisor. This is a local hypervisor of that particular compute host. So if you have compute 1, 2, 3, 4, so each will have separate compute service, compute 1, 2, 3, 4, and that compute will be mapped with the local hypervisor. So suppose if you want to launch a VM, so you need to run commands. You need to run certain command. That command is possible only with hypervisor. But this is, you can say, a single package. So Nova Compute Service. So Nova Compute Service is a combination of Nova Compute and a local hypervisor. But local hypervisor is a means hypervisor is a local tool. You can say local software. It is not part of OpenStack Nova service. So similarly, here you can see if it want to Nova front end, Nova compute, Nova scheduler, or Nova, you can say Nova scheduler. So these services, you can have different services. And if it want to update something in database, it should go, see, it depends on you. You want to expose your database directly to that service, or you don't want to expose your service to that database. For example, if you see Nova compute does not have any access to Nova database, whereas Nova Conductor has access to database, Nova API has access to database, Nova Scheduler has access to database. But if you see these two services, they have only read-only permission. They can only read whatever present in database. They cannot create any information. That has to be done by your conductor and compute. So these things you need to decide if you are designing your service. Do you want to give access to your database from your service, or you want to skip it? So for example, if I don't want to give access, I can remove this lag. I can say you want to talk to database, go to this particular node and then talk. If you node, sorry, not node, service. So if you want service want to talk to database, go from this channel, but don't go directly. So this is totally up to you how you want to design your service. So this is a way how we design services in OpenStack. So I hope the concept of service design is clear to you. In this way, only whole services of OpenStack are designed. All major services like Nova Compute, Nova, Neutron, Glance, Cinder, that I will show you later on when we go. So I will show you how the services in detail level.
Sir, can you explain a little bit more about the neutron part?
Neutron part, yes. See, Neutron
Yeah.
internal, if yeah, internal, let me go in that slide. So in order to go to the detailed structure, what I am saying, here is the complete landscape. So over here, let's talk about Neutron. So you are saying OpenStack networking. So here you can see based on the principle I mentioned, this is a Neutron server, right? So Neutron server has its API, Neutron front end API server. Neutron has another service called Neutron agent. Neutron has another service called Neutron plugin. And if you see this Neutron agent, it has local service called Neutron. provider, sorry. And then also it has the Neutron database. So just correlate with what I have explained you right now. It should have one front API. It can have n number of services. It will have a database, and then it will have the direction, whether you want to give direct access of database or not. If one service want to talk to another service, it should go via queue only. So over here you can see Neutron API server front end. It want to talk to agent, it should go via queue. It want to talk to plugin, it should go via queue. But Neutron API does not have access to database, right? You can see there is no flow where Neutron's API is directly connected to database. Whereas in case of Nova, if you see this Nova, it has access to Nova database. Here you can see there is an arrow which goes to Nova database. That means it is totally on the design of the particular service team when they are designing this OpenStack service. See, service team, when I say it is from community software developer, it is not like a normal company. The community software developers, when they are developing software, any kind of service, they decide whether they want to have communication with a database from direct API or not. Here you can see this is Cinder API. Cinder, this is another example of Cinder service. So Cinder has a front-end API. It has direct communication to Cinder volume, but you can see it does not have access to database. So Cinder API cannot directly talk to Nova database. It should go via Cinder. So they have designed in such a way that you should talk to this. Okay, one more thing, let me tell you. If you want your service to not to go directly via messaging queue, then also it is possible. Suppose if you say it is a local communication, means service one want to talk to service two, and I don't want to go via channel. I don't want to rely on this channel. Rather, I want to have a local path. That is also possible. So that is why I said it is a concept. It is not like you will find same thing for Nova, same thing for Neutron, or same thing for Cinder. You will find similar. So there is a difference between same and similar. So concept you will find similar. If you want to have a direct path, that is also possible. If you don't want to have a direct path, you want your service to go via messaging queue, then also it is possible. So here you can see this is complete landscape. Differences, try to understand what is the difference between Cinder and Neutron. Neutron, this is API. Always remember the front end is API for any service. So if you see this is Swift proxy, this is Glance API, this is Nova API, this is Cinder API, this is Neutron Server API, this is Keystone API. So all the services has an API server. If your service want to talk to another service via queue, you can do via queue. Or if you want your service to directly talk to database, you can give access. Or if you don't want to give access, that is also up to you. That if you want to expose your database to API or not. But remember, one service can have different type of subset of services, like Neutron agent, Neutron plugin. So here you can see Cinder volume. It has this inbuilt part called volume provider. It can have Cinder scheduler. Similarly, if you go with Glance, you will see Glance API, Glance registry, and then Glance database. Here you can see Keystone API. Keystone has direct access to database, token backend, catalog backend, policy backend, and identity backend, means database. Swift, if you see Swift has one service, then it has MAM cache D. This is one another thing. Then account, container, object, and then you have access to your database. So in this way, you design your service. Means this is the principle how you design. Okay.
Okay, sir. Thank you.
Any other question? See, this is a complete diagram of OpenStack. If you go in this diagram, you will understand whole OpenStack, how it is talking to each other.
Okay, sir.
In case anyone no other question, then let me move to the next slide. This is the high level view of your OpenStack. So high level view of OpenStack, when I say, so see, very first thing on the bottom is your physical data center. Physical data center means your physical servers which are connected. Then you have your storage, switches, routers, everything, but no operating system. No operating system means any server you are putting in your data center is not having any operating system. This is blank data center. On top of it, you install a software called OpenStack. OpenStack. So one more thing, let me clarify. OpenStack software is only installed in the server. You don't install OpenStack software in any switch, or you don't install OpenStack software in any storage or in any network switch. You only install OpenStack software in your servers, and that server, when you're talking to your devices like switches, storages, it is going to transform your resources into virtual format. This software is going to be responsible for your conversion. So you give this input, you give blank data center, and then on top of it, what you are getting output, you are getting bare metal provisioning, one of the major services of OpenStack, virtual machine and container. See, you know virtual machine. If you deploy OpenStack in your physical data center, you get virtual machine. But these two things are new to you because how many of you have heard about bare metals? Bare metal on top of OpenStack. Anyone? No? Okay. So see, bare metal basically we call it as physical server. So suppose you have a data center and you want to go with your legacy mode. Legacy mode means you want to go to your data center and build your own physical server, deploy, power it on, and then do network configuration and all those things, and then deploy your software. Means legacy mode, bare metal. But because nowadays the data centers are infrastructure as a service, because data center are now cloud data center. This is not a traditional data center no more. It is a cloud data center. So when you say cloud data center means you don't have access to any of the physical devices directly. Rather, you have an interface called OpenStack, a software installed. That software is going to provide you whatever you need. So virtual machine is one of the famous, you can say, famous service in OpenStack, very famous. But bare metal, how this use case is possible? Yes, this is possible. See, for any application which want to go with a bare metal deployment. So when you say bare metal deployment, then that particular application owner should go to data center, right? He or she should go to data center and then build his own physical server and perform all the activity, cabling, power on, console configuration, all those tasks. And then on top of it, that person can do installation of the operating system. But in this OpenStack landscape scenario, what happens? OpenStack will provide you the console of bare metal server. So out of these data center servers, it will give you some dedicated physical server access via OpenStack. Means you will get the console access, that that particular blade or particular server will not be having any operating system installed. It is a blank operating system. You directly get the console access and you expose, you share with the user. So when user is connecting the OpenStack GUI or connecting to talking to the OpenStack front end, the user is going to get an option for connecting directly to the console of the physical server. And then from over there, user can install operating system directly. So this is another, you can say, not very famous, but yes, OpenStack support bare metal provisioning also. So you will get a bare metal server, physical server access via OpenStack. See, the only difference is that you go data center and perform. Here you via OpenStack you get access to the console. So OpenStack is managing provisioning this physical server, but it is not installing any software in that particular hardware. It is not even going to do anything. Only administrative task it is going to maintain. That is, it is going to add a new node in its cluster, and then it is going to provide you console. From that console, you change password, and then you install whatever operating system you want to install. So OpenStack is not going to delete or install its own software. This is very unfamous service in OpenStack.
Sir,
Now,
1 minute. Sorry for interrupt you. Sir, what is
yeah,
the difference between that installation of through Packstack and Triple O? So in that
okay.
Packstack, that bare metal concept is not there. But in
Mhm.
Triple O, I have heard about that bare metal concept.
See, bare metal is a terminology we use for physical servers. So any physical device without any software installed, without any OS installed, is called as a bare metal. Means a dumb device which does not know how to operate. The moment you install any software on top of it, like operating system, Windows or Linux, then it becomes intelligent. So that is the terminology given to the physical servers. Now talking about Triple O and Packstack, see, these are the two way to install OpenStack. two method to install OpenStack. So suppose you want to install OpenStack for your customer, there are two possible way. Possible way means not software. I'm not saying software. Software still remains same. I'm saying the method you deploy software. There are two different methods. In Packstack, you basically, it is first thing, let me tell you, it is a very depreciated method, not being used anywhere nowadays. And it is recommended only for your learning and development purpose, not for any commercial usage. In Packstack, you basically have an operating system installed, and then on top of it, what you are doing, on top of it, you are creating one, there is a question file, basically a questionnaire. You just give answer to that questionnaire and you just let it run, and then there is a puppet. That puppet is going to take care and is going to install everything. Means you just configure, you just give answer to your questions, means the question which is being asked, like what will be the, how much compute you want to have, how many nodes you want to have, and what should be the network to be used. These basic information you provide, and then Puppet will take care. It will do installation of that Packstack. But Packstack is very depreciated method to install OpenStack nowadays. Triple O is a method where you have full control over the commercial setup. Triple O, basically you have a under cloud. You call it as the you can say life cycle manager. Lifecycle manager means in commercial setups, you are going to have controller. So you divide your software in different role. One is your controller and one is your compute. So controller is only going to control your OpenStack architecture. It is not going to take any action. Compute is only going to host your virtual machine. It is not going to make any decision. So you just simply tell to your compute, deploy this VM, install this particular, create this VM, but it does not know which particular VM you want to create. That you have to tell, and that telling part is done by your controller. Now coming back, in Triple O architecture, you have a lifecycle manager which is managing your whole architecture. Means if you want to shut down your VM, you can do with the help of lifecycle manager. If you want to add a new node, you can do with the help of lifecycle manager. If you want to upgrade your whole data center, you can do with the help of your lifecycle manager. But in Packstack, you don't have any such privileges. In Packstack, you have simply like one node controlling another node. If the controlling node, and that is also participating in launching host VMs, means that node is loaded, is bulky, it is having extra software. So you don't have privilege to utilize your complete hardware because most of the things are already being utilized by your operating system. So Packstack is never I don't see Packstack being used anywhere for any commercial purpose. Even Triple O nowadays is now getting you can say it is very like people are not following Triple O also. They are moving to new advanced options. Okay, so Triple
Okay.
O right now you will find in industry everywhere. Everywhere you will find all the products in industry, especially Red Hat. If you say Red Hat OpenStack has a node called Director. So you have to first install Director node, and then Director node will install your complete commercial setup, means complete OpenStack. So that means your vendors are already following this triple O architecture. So this is the difference between these two. Yeah.
Okay. Thank you. Thank you, sir.
So as I was saying that these
Hi,
bare
Krishna.
metal. Yeah. Hi.
I have a question here. Like
Hmm.
you're saying that this is the physical data center, and over there the OpenStack is installed on the servers. Okay,
Yes. Yes.
but
Yes.
you told me that this is not the physical data center; it's the cloud data center. Data center. So, is there any virtualization layer between this data center and OpenStack, like a hypervisor or
No.
something?
No. 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 OpenStack itself is having an hypervisor.
Okay.
So this physical data center, when I say like normal cloud means not, it means cloud data center means what I mean to say is that
Mm-hmm.
if you want to access this data center, the only way possible will be via OpenStack. But if you
Okay.
say that no, I want to go to data center and I want to manage my rack myself, then that means that data center is not a cloud data center. Cloud
Mm-hmm.
data center, the word you use cloud, that means everything should be handled via OpenStack only. And yes, OpenStack itself provides that hypervisor, which is required for this data center to get converted into virtual board.
Okay.
Okay,
Thank you. Thank you.
yeah, welcome. Yeah, moving ahead. So there is a third type of service which OpenStack is providing nowadays. Nowadays on OpenStack you find containers also. Means you might have heard about Kubernetes and containers. Kubernetes is an orchestration managing doing life cycle management of containers, but the actual hero of the Kubernetes is container. Now this container, OpenStack is also doing an orchestration. Means or OpenStack is providing a orchestration of this particular container using their own container orchestration technique, and you can directly run container on top of OpenStack. So this is the third use case or service offered by OpenStack: bare metal, virtual machine, and container. These three things are possible with OpenStack portfolio. Now over here you can see that you can connect third-party services with OpenStack. So means what are the different third-party services which you can integrate with OpenStack? One is you can integrate Kubernetes. Means you can install Kubernetes using virtual machine or bare metal from OpenStack. OpenStack will be your provider, and virtual machine or bare metal will be your type where you can deploy your Kubernetes. That is one use case. Cloud Foundry is another way of Kubernetes, you can say, orchestration for containers. So that Cloud Foundry also you can integrate with your OpenStack. Third one is your Terraform. See, Terraform is basically a framework. Terraform is not any software, or you can say it is basically a framework. So what framework it exactly does, like you have something running on top of it, you have some application, automatic application running here. Now that application want to deploy a virtual machine in your OpenStack, then what it should do, it should be having knowledge how to run, create a command, how to create a virtual machine in OpenStack. What are the commands required? So the intelligence to create a virtual machine means you have OpenStack flavor create, you have OpenStack network create, OpenStack image create, OpenStack server create, then you have OpenStack security group. All those logic is present in this framework called as Terraform. So if you use a Terraform, then you can simply give order from your application, and it will install your virtual machine. It will make your virtual machine up and running on the OpenStack platform. So this is one way you can do automation. So Terraform is basically used for automation of the VM deployment. So if you want to automate your VM deployment, you can use Terraform. Now there are other way to talk to OpenStack. As I mentioned, if you remember, I mentioned there are two ways to talk to OpenStack. One is the Horizon Web UI. So you have a GUI from OpenStack where you connect and then you can perform all the tasks. There is OpenStack SDK. Now, what is OpenStack SDK? OpenStack SDK is basically a front-end API. So if I go back to my original these diagrams, so if you remember, I was talking about the API. So this API, when I was talking about, it was the API of that particular service. It is not API of complete OpenStack platform. It is the API of particular service. It could be Cinder, Nova, Nova, or any you can say Neutron. But when you say whole OpenStack, so whole OpenStack has a API called OpenStack SDK, OpenStack SDK, and your OpenStack client, which I mentioned that you can use OpenStack client to run command from CLI, is connecting via a OpenStack SDK. So it has an integration with OpenStack SDK, and from there you can run all the commands which you want to do. Like you do OpenStack image list, you can do OpenStack server list, you can do OpenStack network list. So when you say OpenStack network list, or you say OpenStack server list, it is actually connecting to this SDK, REST API. And this REST API is now on the backend talking to your particular service. So if you say, let me take an example, if you say OpenStack network list, so the moment you say OpenStack network list, it will talk to your Neutron API. It means OpenStack SDK. You have an integration of your client with this SDK. SDK will talk to the Neutron API server. If you say OpenStack image list, that means it is going to, where is that glance? So it is going to talk to OpenStack glance API server. It means your OpenStack SDK. So I hope you are clear what I am trying to say. When I say from GUI, so GUI has its own interface with each API. So GUI has its interface with your glance. Over here you can see this one, Horizon GUI. it has the access to API, Swift API, Nova API, Cinder API, Neutron Server API, Keystone API. It has connection with all the APIs, and based on that, it will provide you access to that particular service. In addition to this Horizon, you have this particular entity called OpenStack SDK REST API. This REST API will provide you access, and on the backend, you can over here you can have OpenStack line, and then you simply run a normal human understanding command like OpenStack network show, OpenStack Neutron like server list, or you say OpenStack image list, and then on backend it is going to talk to that particular service API and going to get you the response. Or if you perform any operation, delete, create, get, everything is possible. And this SDK you can integrate with your Terraform. That is also possible. You can integrate with your Terraform. So there are multiple ways to talk to OpenStack or send request for your automation. So I hope this was clear. Any other questions if you want to ask, please feel free to ask. Anyone has any query? No. So next.
Sir, can I get this PPT?
Yeah, sure. I will share this PPT. I will share after this class. Please do one thing.
Okay.
Either send me a sample email if you have my on this email ID, so that I can add you in the distribution list. Or if you have my WhatsApp number, you can message me your email ID. And either way, you can just send me your mail ID so that I can add you in the distribution list.
WhatsApp number I have, sir. Okay, I will text you on that only.
Okay.
Okay,
Yes.
thank
So
you.
just send me your email ID. I will send.
Okay, sir. Okay.
Okay, then let me stop sharing.